Hello and hi everyone. Me, Hanzala, with Smita, Ain and Aidil. We're going to talk about the engineering talk that we had the other day for engineering seminar. The talk by engineer technologist Mohd Ikhmil Fadzrizan Bin Mohd Hanif. IR Ikhmil is a professional engineer with the Board of Engineer Malaysia (BEM) and a professional technologist with Malaysia Board of Technologies (MBOT). IR Ikhmil holds Bachelor of Electrical Engineering Control, Instrumentation and Automation and Master of Science, Instrumentation and Control Engineering. He has more than 15 years of working experience in instrumentation and control engineering in oil, gas and petrochemical industry, and also working experience as senior lecturer in institution of higher learning education. In his talk about offshore life, we know that there are 4 types of offshore work base: floating production storage offloading, central processing platform, drilling rig and barge. For floating production storage offloading, their working hours is 24 hours operation, divided into 2 shifts. Both is 12 hours, 6 am to 6 pm and 6 pm to 6 am. They get 6 times meals per day: breakfast, lunch, dinner, supper and tea break for every 3 hours. The offshore rotation for regular crew or production and maintenance crew is 14 days work and 14 days off. The best thing is recreational and entertainment. They get Wi-Fi, table tennis, pool or snooker table, even PlayStation or Xbox games, futsal court, jamming studio, gymnasium, cinema and even swimming pool. Okay, for drilling rig, for drilling work over wireline activities, their working hours is also 24-hour rotation, 2 shifts, 6 am to 6 pm and 6 pm to 6 am. They get 6 times meal per day: breakfast, lunch, dinner, supper and tea break every 3 hours. The offshore rotation for regular crew, operation and maintenance crew is 28 days works and 28 days off. Their recreational and entertainment is Wi-Fi, pool, snooker table and gymnasium and TV. And for barge, they get to work for pipe laying, geo survey, exploration, accommodation barge, ship tanker and cargo tanker. Their working hours is also 24 hours operation, divided into 2 shifts, 6 am to 6 pm, 6 pm to 6 am. They get 6 times meals per day: breakfast, lunch, dinner, supper and tea break every 3 hours. The offshore rotation for regular crew, operation and maintenance crew, they get 28 days works and 28 days off, or 6 weeks day off and 6 week day works. For office, they get 6 months work, 3 months work and 1 month off, or 6 months work and 3 months off. Their recreational and entertainment is gymnasium and TV. Okay, that's all from me. And for you?
Okay. Hello everybody. I'm here to talk about what are the main works of control and instrumentation engineers. So basically what they do is they are responsible for designing, developing, installing, managing and maintaining equipment which is used to monitor and control engineering systems, machineries and processes. So basically their job is to make sure that these systems and processes operate efficiently and also safely at the same time. So as an instrumentation engineers are in high demand right now, so they are very marketable. At the same time, they are also valued in among other engineers. So a skilled instrumentation engineer with sound knowledge of operations and machinery controls is in great demand in private sectors. The average salary for instrumentation engineers is in the private sector ranges from INR 300,000 to about 400,000. So their salaries are actually pretty much high. So as fresh candidates having a degree in instrumentation engineering are offered some good job opportunities in the electrical, mechanical, as well as electronics sector. Additionally, because of the multidisciplinary nature, an instrumentation engineer can also work within and outside of the industry. As a control instrumentation engineers are responsible for designing and everything as have been mentioned before this. So that's all from me, and I'll be passing it to Ain.
Okay, hello everyone. So today I'll introduce to you what is DCS or ICFS. Okay, DCS is Distributed Control System, which is a platform for automated control and operation of a plant or industrial process. DCS combines the following into a signal automated system, which is human-machine interface, logic solver, historian, common database, alarm management, and also common engineering suite. It is also known as Integrated Control and Safety System, which is ICSS. DCS can cater large scale of I/O up to 100,000 I/Os. Example like Petronas Rapid, Shell, Gumusut are also backup platform. So, what is DCS components? DCS components consist of controller, I/O module, communication module, engineering workstation, also operator control station. What's inside in the controller? It process communication control, respond as per logic program, and also redundancy. For the I/O module, it's for input and output signals, analog and digital, 8, 16, and 32 channels per module. It's also for hybrid universal I/O module, which is the latest one. For the communication module, it's a Modbus protocol. The number 4 is engineering workstation, which is engineer station and configure logic program or download program. For the operator control station, which is human machine interface or known as HMI, is for operation control line process. CPU or processor module, it contains a CPU, main processor, and it's for redundancy or also known as a backup. For the I/O module, analog input such as pressure, flow, level, temperature transmitter. Analog output, it's for control valve or heater. Digital input for push button, limit switches, and digital output for solenoid valve, start-stop motor, or pump. In a traditional I/O modules, they have four sections, which is junction boxes, junction box, and marshal cabinet, followed by safety manager. For the engineering workstation and HMI, it's for engineering workstation, operator station, or human machine interface HMI. Communication module, used to communicate with other DCS system or PLC using Modbus protocol. Example like Yokogawa DCS, Emerson DCS, or Allen Bradley PLC. For the Modbus communication, it has a DCS system, PLC Modicon, PLC Omron, and also PLC GE Fanuc. Instrument signal. First is analog. As we know, it's a transmitter. Current 4 to 20 milliampere. Voltage 0 until 10 volt. For the process, it's used a pneumatic signal 0.2 to 1 bar. Digital, it used like a binary 0 or 1, which is used as a limit switch, mechanical and proximity. Contact is used as open or closed relay, also known on or off. That's it for me. For the field instrumentation in process industry, I will pass to the ID.
Okay, now I will explain about the field instrumentation in process industries. So, first of all, what is instrumentation? Instrumentation is equipment used for measurement, monitoring, and control the process plant. So, it divides with two parts, which is instrument measurement and final control element. So, what is instrument measurement? First, temperature. Second, pressure. Third, level. And last, flow. What is piping and instrumentation diagram? So, a piping and instrumentation diagram, or PNID, shows the piping and related components of a physical process flow. It's most commonly used in the engineering field. So, now I will explain about the transmitter. Transmitter have 7 types of transmitter, which is temperature transmitter, pressure transmitter, flow transmitter, level transmitter, DP level transmitter, guided with radar level transmitter, and wireless transmitter. So what is temperature transmitter? Which is measure the temperature on the process, remote and direct mountain type, thermocouple height temperature, and thermocouple and RTD. For example, type J and type K. What is pressure transmitter? Pressure transmitter is measure the pressure inside pipe or vessel. What is the unit? The unit is kPa(g) or bar(g). For the example of pressure transmitter is direct mountain or differential pressure. So the type of flow transmitter is orifice flow meter, vortex flow meter, turbine flow meter, and Coriolis flow meter. So the types of level transmitter is differential pressure level transmitter, displacer level transmitter, float type, and guided with radar level or non-contact radar level. So next, the DP level transmitter, which is closed tank dry leg calculation. Okay, for example, we have 100 equal to H plus D in bracket SP. For example, 10 plus 100 times 2 0.75 equal to 82.5 H2O. So next, I will explain about the wireless transmitter. The types of wireless transmitter is smart wireless gateway, wireless PAN network capabilities, and hydrocarbon leak detection. Okay, last but not least, I will explain about the valve. First of all, the types of valve is on-off shutdown valve, blow-down valve, and last, control valve. The on-off shutdown valve is for emergency or isolate process. Second, field close. And the third, control from DCS or shutdown system, which is SDS. And the last but not least, solenoid valve will open and supply the instrument air to the shutdown valve actuator. So the blowdown valve is for emergency, depressurized process line, or we can say to field open or control from shutdown system. And lastly is control valve. Control valve is pressure control valve or temperature control valve or flow control valve. And the second, control from DCS and driven by pneumatic in bracket instrument air. Okay, that's all from me, and yeah, that's all from me.
Okay, thank you, Aidil.
Ansalam, Ain, and Yashmita.
Okay, thank you, Aidil, for the
So
summary.
thank you.
With that, that is the end for our summary. Thank you for watching. Bye.